Hi guys, today we're going to build a particle system, and particles are used to create visual effects in many games, and most games use them to enhance the visual experience. They're not game entities if we're talking about entity component system. It's slightly different unless you want your game particles to affect the game logic. Only in that case will you need to use them as entities, and for this tutorial we'll create them as just visual effects. So we're going to create I'm going to create a new package. You can create new project if you want to. I'm going to name it particles, and we'll create particles, which is the entry class with the entry point. And this is our typical JavaFX application. In the main was just launch our JavaFX application with arguments. In the overlaid start method, we set our scene populated with create content method, and the implementation will be right here. The root node will be our just pane, which we'll set preferred with and height 600 by 600, and return root. Now, because we don't want our particles to be nodes within the scene graph, because this will create CPU load, and we don't want that, so we will use a canvas, which is, as far as the scene graph is concerned, just a single node, and we'll populate the canvas with our own particle drawing. And we can create canvas in JavaFX just like that. We'll also specify width and height of the canvas. And finally, we need to add the canvas to our root node, which is essentially just a single node within the scene graph. Now, we will need to obtain a graphics context for our canvas, and this is the context on which we're going to draw. If you've done any swing rendering, this drawing, this should be fairly familiar. We're also going to need a animation timer, which is how we implement our main loop within JavaFX. And we'll need to first import and then override this method, or rather implement, where we're going to call our onUpdate. And here is the implementation of our update method. Now, this is where we're going to update our particles and draw them to the canvas, which will then be rendered off screen by the JavaFX platform, which we do not have control over. Once we've created our timer, we can start it, and this will call the handle method every or 60 times a second, so every 0.016 and 6 recurring seconds, which will delegate the actual logic to our onUpdate method. And this is where we're going to create or write our code. Now, for particles, we will also need to have a data structure, which we'll create in a different class, separate class called particle. we'll need the essentials, so X, Y, and these are coordinates of the particle. Then we'll need a velocity, which can be represented as 0.2d, which has the same implementation as vector 2d. Now we'll also need radius, so our particle is going to be represented by a circle, and hence just single variable to hold the size of the particle. If you're using a different shape, say a rectangle, you might want to pass width and height and store them. Then color. Paint is the superclass for JavaFX color as well, so you can pass things like gradients if you want to. We'll also specify blend mode, and this will determine how the particle on top will be blended with the particle below the particle we're currently rendering. So it will sort of blend the two particles together. And I think that's it. So public particle. Actually, we're going to, oh yeah, we'll also need something to hold the value of current life for the particle. So that when this value gets to 0, we will discard the particle, so we'll destroy it. And I'm going to just create a constructor using fields and select all of them. So this is a sort of shortcut for creating a constructor which initializes all the fields. Although we don't really need to initialize a life, we'll rather need a decay or something. Decay. Instead of calling it life, we'll call it expire time. So we'll pass this value in seconds, and this is going to be the time per frame, which is 1/60, divided by the expire time. I think this should give us the right value to reduce life by every update call. So the update call for our particle will look like something like this. So first of all, we move our particle, velocity get x, and get y. And we also need to perform the decay, which reduces life by a certain amount based on the expire time. And that's pretty much it. Public void render, and this is where we're going to pass our graphics context on which we're going to render. So we'll first set global alpha, and global alpha just means the alpha for all the operations following this particular call, and we'll pass life. So when life goes to 0, the alpha will be 0, means the transparency will be completely transparent, we won't see the particle. Set blend mode, or is it global blend mode? Yeah. You typically have the same blend mode for the whole effect, not just a single particle. though by specifying it for a single particle you can get better effects. What else can we do? We'll need to set fill, which is color, and finally we just draw it, fill oval. Yeah, that will give us, if we specify the same width and height, this will give us a circle. So that's X, Y, radius, and radius. That should do it. We also need to know whether the particle is alive or not. So public boolean is alive, which returns life is greater than 0. Yeah, that should be sufficient. We will need to have a list of particles. And these are the particles that exist in the game world or in the scene graph. So basically alive particles. On update, we're going to go through all those particles. Yeah, we're going to use an iterator because at some point we need to get rid of the particles, and removing can only be done through an iterator or sort of in the same loop. We don't want to loop go through the list twice, so we're going to use the same for loop. Iterator particle. I'm going to import the iterator first. Iterator particles iterator. While it has next, we don't really need to pass anything in there. So we obtain the particle. By calling next on the iterator, we update the particle. We then need to, well, at this point we can check whether the particle is alive or not, because there is no point in rendering dead particle. So if P is alive, or rather is not alive, then iterator remove current element. And continue. So this will skip to the next cycle of the loop without continuing the execution of the current cycle. And if you type break, then this will exit the loop completely. And we simply want to skip over the element so we don't render dead ones. Render, and we just pass our graphics context. So instead of creating nodes, like I said, performance issues might arise, and another thing why we use nodes for entities is that it's easier to represent game objects like real objects. So you can sort of have reference to that. You can you can query your game object for different states. You can apply various functions. And when we're using graphics context, what we typically have is the sort of state machine. We are just setting state and calling different fill functions, so we don't really have objects. Alright, that looks okay. Now we need to populate this list of particles, and it will be done just before the iteration. And particle population usually happens through a thing called Emitter. And we're actually going to create an abstract class so that you can create your own implementations of the emitter. And the one we're going to use today is going to be fire emitter. So fire is kind of the general type particle effect that is used in many games, whether it's for a fireball effect, meteor effect, or just a torch. And we're going to have a method that returns an abstract method, so meaning that the implementation is up to you, or is up to the implementer of the subclass. And we'll just call it emit, which might as well take x and y, which are the coordinates where to emit those particles. And we're going to create another class called fire emitter, which is a subclass of emitter class. So we're extending our class, and this is where we need to return particles which kind of create a fire effect. Now in the particles app, we will have a generic emitter. As you can see, we're not specifying the type of the emitter. We're just naming the type as the superclass, and by instantiating it to a subclass, say fire emitter, or it could be smoke or any other particle effect, we can easily change the behavior of particles. And this is a really nice feature of object-oriented programming, or rather polymorphism, so that you don't really need to change a lot of code, just the instantiation part. And if you have factories and if you use dependency injection techniques, then it's even easier. But for now, we're just going to do instantiation in the same class. So yeah, just before iterating over the particles, we need to emit those particles, which we can do by particles add all. We'll add a new collection from emit, and the x and y will be, say, the middle. So our root is 600 by 600. So this is essentially the size of our application, and right in the middle we will emit our new particles. Now we will need to have a number of particles value. This should be this should have a public accessor somewhere, so that you can modify this value according to different settings. You might want to have more particles or less particles. And when it comes to particles, most of the stuff is dependent on what kind of effect you're trying to achieve. And yeah, most likely you'll be tweaking these values from one game to another. And here we are going to create a new particle and populate. Now our particle is created by x and y taken from the parameters. Then we have velocity. Fire particles usually go up, So we'll need to specify a velocity of in x direction. Math random should do. So that's for the x direction, although this gives us value between 0 and 1, so we need to subtract 0.5 so that it also sometimes goes to the left instead of just going to the right. As for the for the y value, we need to make the particle go up significantly, which is, we'll also use a random value, because we don't want all particles to have exactly the same velocity. And multiplied by -4 or something. Those values will need to be tweaked at runtime, really, so that you can actually see how it performs. So we'll just use roughly sort of approximate values and then see how that goes. Radius 10, expire time 2 seconds, color red, or we'll use RGB method to create our color for red. So it's kind of going to be reddish, so it's 230. The maximum value is 255 for RGBs. Green, say 30 or 40, and blue around 40, 45. Blend mode. For fire, it's usually blend mode add, although you might want to play with values. As you can see, there are quite a few that you can use. So this is pretty much the definition of our fire emitter. And if you're going to create your own like smoke emitter, this is pretty much the only thing you'll need to change, and maybe number of particles. Right, I think we're done with the implementation more or less. Let's see how that performs. Oh yeah, we need to clear the graphics context. 0, 0, 600, 600. Or actually fill it with color black so that the effect of fire is more visible. So fill color black. We need to make sure that we set global alpha to 1.0, and we need to set default blend mode, which is source top blend mode. This source over. Can I tell? Oh no, the default value is source over, so we're going to use source over. Set fill black, so instead of clearing the rectangle, we're actually going to fill the rectangle. It's actually nice effect of I don't know, kind of incense fire, or I don't know. Yeah, so we might want to decrease the velocity so it doesn't go too much to the top. We can do this by placing -3. Yeah, that's better. And maybe less variation in the x velocity, so we'll take that and multiply by a smaller amount, 0.4. You also might want to decrease the value of particles. Yeah, so depending on what you do with those values, it will alter the effect. Yeah, so this looks nicer, and if we did -2, maybe slightly larger in the x, this is 5. So this will create this fiery effect, and like I said, you will need to tweak those values to make it fit your own game, because aesthetics is really a sort of subjective thing. Maybe to 15 and yeah, this will create sort of a magical kind of fire effect, sort of purple-ish. And I think this is pretty much it for our small particle system. There's quite a lot of content available on the internet if you want to read about creating particle systems. This is a very sort of basic implementation of one that should be sufficient for small games, although yeah, like I said, you might want to add a few other things. And yeah, this use of canvas is kind of important so that it doesn't clutter your scene ref, because as far as the scene ref is concerned, this is a single node, and rendering it is much easier, and the update of all other nodes is also not going to be such a performance issue. Alright, then yeah, this is it for this tutorial. If you have suggestions or topics for me to cover, just write them in the comments or email me. And thanks for watching.